Hello everyone. In this video, we're going to be solving a rational equation, which is going to turn into a polynomial equation. And this problem is from Russia. It's a book called Matematika для старшеклассников. Probably butchered the pronunciation. Sorry about that. But I'll try to share the link with you down below. And it's the author is Brun. So anyways, we have this equation, and I just modified a little bit, turned it into a rational equation from a polynomial because it just looks better on the thumbnail. What can I do, right? So we have this equation where we have a polynomial squared divided by another polynomial equals x squared. So what is the first step we're going to take? Cross multiplication, right? So let's go ahead and cross multiply so we can turn it into a polynomial equation. Of course, we do have a requirement here. We need to make sure the denominator does not equal 0, right? So we got to make sure whatever we do at the end, we need to make sure that this does not equal 0, because that would make the whole thing undefined and very problematic. So under those conditions, we can go ahead and proceed with the solution. But how do you solve a problem like this? And there's more than one way to do it. So I'm going to present both methods. Let's start with the first one. The first one is usually the more annoying brute forcey method. Okay, so bear with me on that. Let's go ahead and square the left-hand side. That's going to give us x to the fourth plus x squared plus 1. Usually when I have a plus b plus c squared, I use a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ac. Did I say everything right? AB, AC, BC. Okay, you get the idea hopefully. So it's going to look like this: 2x cubed, 2x squared, and then 2x. Great. Now the right-hand side is you're just going to distribute. It's going to be 3x to the fourth, and then plus x cubed plus x squared. Of course, something is going to simplify. For example, you can cross out these x squares and bring everything together. It's probably better to bring everything to the right-hand side and then put it on the left-hand side. Subtract this, you get 2x to the fourth. So we'll be taking care of these two things. We have x cubed, and now we're gonna subtract 2x cubed from it, so it's gonna be minus x cubed, right? And now we have the x squared. This is the only one left, so it's gonna be minus 2x squared. We have 2x and nothing of x on the right-hand side, so it's gonna be minus 2x. And finally, bring the 1 over, and that is going to be minus 1 equals 0. Even though this kind of looks like a symmetrical equation, maybe it is, who knows? Maybe there's a way to handle it. There's a couple ways to handle it, actually. One of the ways is you can divide both sides by 2. Or even better, let's think about it. If I write it as 4x to the fourth, can I make it a perfect square? Probably. Let's multiply both sides by 2. So that we can make this a perfect square. That's our goal, I think. I could be wrong on that one, by the way. So, and then we're going to try to do this. How can we turn this into a perfect square like this? So I'm going to leave this here and put everything else on the right-hand side. So we'll have a quadratic on the right-hand side. That's important. And quartic on the left-hand side. Good. Now we need to add something to both sides to make the left-hand side a perfect square. That may or may not work for the right-hand side, but we'll give it a try. And to find that, you kind of need to think about it this way. This is 2x squared squared. And then it's followed by 2 times 2x squared times, in order to get 2x cubed, I do need a 1/2 here. 1/2 of x. Okay. So that's my next term, which means I need to add 1/2 of x squared to both sides. And of course, it's going to look like this on the right-hand side, because when you square this, it's going to be 1/4 of x squared. So these two can be combined. Okay? Cool. Now, what happens to the left-hand side? It becomes 2x squared minus 1/2 of x quantity squared. You get the idea? A squared minus 2ab plus b squared. And the right-hand side is just going to be weird, like 17x squared divided by 4. You could also separate the coefficient, plus 4x plus 2. So the right-hand side is still a quadratic, which is good. Now we're going to add something to both sides to still keep the left-hand side as a perfect square while making the right-hand side a perfect square. So here's how it goes. If you think of this as a, what would you add to a squared to make it a perfect square? You would add 2ab plus b squared, right? So in this case, we got to find out what that is going to look like. So since this is a, we need to add this and this. So we start with this, okay, a squared, plus 2 times a times b, which is, we don't know what it is, plus b squared, okay? So in other words, this is what we're adding to both sides. Make sense? And notice that this is still quadratic, but with a variable in it, like a b. So when you add it here, the right-hand side is still going to be a quadratic, but it's going to contain a variable b, and my goal is to make that a perfect square. Therefore, its discriminant needs to be 0. From there, I'm going to be able to find the value of b. Hopefully, right? Hopeful thinking or wishful thinking. Now, when you add that to the right-hand side, the left-hand side is not that important because we now know that the left-hand side is perfect square. Great. So let's go ahead and add this to the right-hand side, which is this one, and see what happens. Okay. So we start with 17x squared over 4 plus 4x plus 2 plus this. That is going to be 4bx squared minus, and the 2 and the 1/2 cancel out, leaving us with minus bx, right? Plus b squared. That's what we're adding, in other words, right? So, did I get that right? Minus bx. Yeah, I think so, because we're distributing 2b, or not 2b, by the way. Anyway, so now we get the following: 17 over 4 plus 4b, that's the coefficient of x squared, as you can see from here. And then we have these two things, 4 minus b, quantity x, and then plus 2 plus b squared. So we've taken care of these, those, and these again. Okay. So this needs to be a perfect square, which means delta needs to be 0, the discriminant, right? How do you write the delta? B squared minus 4ac, the coefficient of x, b squared minus 4a times c. And c is b squared. Guess what? This gives you a cubic equation in b. If you solve it, then you get the value of b, and then you plug it back in, and then you just solve the resulting equations from there. And again, this is going to take a while, but I'm going to leave it at that for you to finish up, because I'm about to introduce the second method. Ta-da-da-da. This is my favorite, but again, you'll decide which one you like better. Cool. Now let's go ahead and take a look. One more time, let's rewrite our original problem. Not the original one, but after we cross-multiply both sides, we got this, right? And remember what we said, we don't want this to be 0. Of course, you always have to check it. Make sure that this does not equal 0, because that was in the denominator, remember? So that kind of slightly modifies the problem. As long as the denominator has no solutions that are solutions to the whole equation, we should be good. Anyways, now what am I going to do here? I'm not going to distribute and turn it into a quartic, because quartics are annoying. And this is a competition level problem, or even a competition problem designed for high schoolers, right? The book contains 300 problems that are hard. And again, I'll try to share the link with you down below, so you can hopefully take a look at the book. If you are in Russia, then you can purchase it, or maybe somewhere else you can order it. I don't know. Maybe I don't think there's a translation. So we're going to go ahead and divide both sides by x to the 4th power. That'll do the trick, and you'll see what I'm talking about when I do that division. But the presence of x plus 1 in both of these equations is a very good thing. Now x squared goes into x to the 4th power, x squared times, so that cancels out and leaves us with x squared here. And on the left-hand side, because they are both squared, I can kind of write it like this: x squared plus x plus 1 divided by x squared, and then the whole thing is squared. And here I can divide everything by x squared to split it up into 3 plus 1 over x plus 1 over x squared. Great. What happens on the left-hand side is also interesting because we can split it up into 1 plus 1 over x plus 1 over x squared. And of course, that quantity is squared. And notice that we're getting the same thing twice, which calls for substitution, right? So notice that we have this thing twice. So now I can use my super duper powers and use substitution. It's up to you if you want to call the whole thing something else. You can also do that, but I'll probably just call this y. And then this gives me 1 plus y to the second power is equal to 3 plus y. This is a little easier, I think, to do. Then I'm going to expand it. Y squared plus 2y plus 1 equals 3 plus y. We're going to go ahead and subtract y squared plus 2y minus y. And then 1 minus 3 is negative 2. And guess what? This is factorable. Now we can factor it into y minus 1 times y plus 2. This is a trinomial. You should know the trick. And here we get y equals 1 and y equals negative 2. Beautiful. This is what makes these problems awesome. And now we got to remember what y is. It's 1 over x plus 1 over x squared. So from here, 1 over x plus 1 over x squared is equal to 1, which means we can multiply both sides by x squared. That gives us x plus 1 equals x squared. And then x squared minus x minus 1 equals 0. Great. Now, we can solve this equation very easily. The roots are going to be coming from the quadratic formula, negative b plus minus the square root of b squared minus 4ac, which gives you the root 5. Uh-oh, the golden ratio pops up again. Of course, we got to check these solutions against our criteria. But if you think about it, do you think these two equations will have a common solution? 3x squared plus 3x plus 1. Let me write it down here. And the other equation. If they did have a common solution, then we could just work with both of these equations. Let's just say add them up. That should give us x equals 0, but x equals 0 is not a common solution, which means we're actually not violating this condition. Okay? Great. What about the other one? Let's go ahead and check it out. If you set y, which is 1 over x plus 1 over x squared, equal to negative 2, and again, do the same thing. Multiply both sides by x squared. X plus 1 equals negative 2x squared. And put everything on the same side. 2x squared plus x plus 1 equals 0. And again, with the quadratic formula, this becomes negative b plus minus the square root of b squared, 1 minus, uh-oh, Houston, we have a problem. We get complex solutions. Okay, we're not really interested in complex solutions because this channel is usually about real numbers, but I have another channel which you can check out. It's called aplusbi. That channel focuses completely on complex numbers. And notice that I did not say complex analysis, but I said complex numbers. Anyway, so these solutions should also be good, I think, but I'm going to double check because I'm curious, like, what would happen if this was equal to 0, right? If this was equal to 0, then we would be getting x equals negative b plus minus the square root of b squared, 1 minus 4ac, which is 1 minus 12. So it looks like we are safe, okay? Because these are not the same as those, so we're good. This is not going to be 0. X is not going to be that. So all the solutions look good to me. I hope they look good to you too, because this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and don't forget to check out SyberMath and aplusbi, and bye-bye.